circuit. First and foremost, when we push the button, the lamp that is on must be switched off. Therefore, we utilize a transistor in order to switch the current, and for doing so, we connect the button with the transistor's base with the resistor and the collector with the LED via a jumper wire. The reason we use the resistor is to shun from any burning cases. Subsequently, when we push the button, the electricity current switches, resulting in the circuit being complemented by not the lamp side but the other one.
Now let's construct AND gate. Initially we position the buttons, ensuring they are connected to the positive current source using jumper wires. Next, we connect the buttons to the transistors through 2 kilo ohm resistors to limit the current flow. The key point here is the placement of resistor and jumper wire crossover, which is linked to the button. When the button is pressed, the button's legs meet, allowing electricity to flow. If the button is not pressed, no current flows. One side of the resistor is connected to the base of the transistor. When the button is pressed, electricity reaches the base and activates the transistor. To ensure current flows properly, the emitter is connected to the negative source. Jumper wires are used to link the two transistors, ensuring connectivity. Next, we use a 330 ohm resistor and a jumper wire to connect the collector to the positive source. To connect the third transistor's collector to the same positive source, we use a jumper wire and then connect its emitter to the negative source to complete the current flow. Finally, using a resistor and a jumper wire, we connect the collector to the positive source. The jumper wire then connects the LED to the positive source, and another jumper wire connects the LED to the negative source, ensuring proper current flow through the circuit.
This structure you get to see right now is the framework of so-called OR gate. OR gate is a circuit that gives an output of 1 or true if at least one of its inputs is 1. If all inputs are 0, the output is 0. We start by locating the buttons on the breadboard, which are responsible for giving the inputs to the circuit. Then, they are getting ready for doping with the construction of jumper wires to the breadboard, allowing current to flow. Transistors and resistors are connected to the circuit in the right slots with an objective of switching the current and confining the current tension, respectively. Ultimately, the LED and the battery is joined to the circuit in the end to both complement it and obviate any potential risks that may occur. This is a framework of the so-called NAND gate. It is acquired by the concatenation of OR and AND gate. It's a circuitry that provides an output of 1 when both inputs are 0, and an output of 0 in all the remaining cases.